Hey guys, it's Obi here. We're going to continue on this week talking about electricity. So, last week you guys watched 3 separate videos on electricity. You watched a video on voltage, amperage, and resistance, okay? Now, electricity is extremely important. There is not a single component on an automobile that does not use electricity in some way, shape, or form. We use it for basically everything on a car. So we are going to spend a good bit of time making sure you guys understand what electricity is. It's a complicated subject. It seems simple on the surface, but when you start getting into it, it can get confusing, okay? But we have to do our best to try to understand this. So what is electricity? Electricity is a form of energy consisting of charged particles. But how do we actually use it? So we can harness the energy potential of electricity by forcing the current or the electrons to do work. This can be the creation of heat, light, movement, or for communication, to name a few examples. And if you think about it, we use electricity to power our headlights. We use electricity to control the actuators in the HVAC system, or to move our window up and down. And we use it to communicate between module to module. Okay? So, we're just going to review the 3 topics we talked about last week. So, voltage is the difference in electrical potential between 2 points. The power source is going to decide what the maximum voltage for the system actually is. And what is our power source on a vehicle? If you guessed battery, you're right. Okay? So voltage is the electrical pressure that's going to cause electrons to flow through a conductor. So if we're looking at this, we see our voltage. Our voltage is what's going to push or entice those electrons to continue moving down the line, okay? Voltage is also what's going to be able to make voltage jump a gap. If you've ever seen a high voltage line arc, or you ever seen a spark jump across a spark plug, it's the high voltage that forces it to jump that gap, okay? Amperage is the flow of electrons from one point to another. This is measured in amps. And if you guys remember in the video, that 1 amp is 6.82 to the 10th billion coulombs, I believe. That is a lot of electrons flowing. So we need to remember a very simple measurement, that our amperage is current flowing from one atom to another, okay? Which means that one electron is coming from the outside, going to the outside ring on another electron, then jumping, so forth across. Now, it's a pretty simplified example of what's going on, but that helps illustrate the point, okay? Now, amperage, we need to understand, is a very real movement. This is why it does not take very much amperage to harm somebody. So it really only takes about 1 amp to be able to kill somebody, provided it takes a path through your heart. So amperage is what we really have to be careful of. We do not want to mess with amperage, okay? And then resistance, the final one. So resistance, electrical resistance, is the opposition to the flow of current in an electrical circuit. Resistance converts electrical energy to thermal energy, and in this regard is really similar to mechanical friction. Okay, so anything that's going to slow something down or make it not want to go in a particular direction is resistance. Okay, resistance is all typically shown in an electrical circuit to be given off as a sign of heat, but anything that's going to resist current flow is going to be a resistance. So how do they all work together? So this is the nice little drawing that I kind of prefer. You can see that we have our volts, our ohms, and our amps. Okay? So we always have to remember voltage is pressure. It is going to push the amperage down the line. The amperage is a flow. Okay? So it is how much is trying to go down the line. And resistance is the restriction. So the amperage is going to be the flow of the line, the volts is going to tell you how much is going to flow, and the resistance is going to restrict that flow down. Okay? So a load is also going to be known as a resistance, okay? Any electrical circuit is going to want to have a resistance because you don't want to have all of the amps freely allowed to go from the positive to the negative of the battery. That's kind of a problem. We don't want that. If that happens, that means we have a bunch of current flow. So if you put a wrench across the battery, it gets really hot because all the amperage wants to go right across that wrench really fast, right? So we need to have, we need to have some resistance to allow that to actually work. Okay, so that kind of sums everything up. Tomorrow we're going to continue on talking a little bit about this, but that's it for today. I'll talk to you guys later. Bye.